opposite? Let's see, opposite, opposite, no, not opposite. So I'm not ticking that box. Everybody got that? So now I need to come down to, well, is there a place where they're both true? No, no, yes. So I'm gonna tick this box and only that box. So everybody understand? Because if it's consistent, it's not inconsistent and vice versa. All right, so I'm gonna always tick one of these two, okay? Any questions so far? Okay. So we're on to part 4. Okay. And so the final thing, and people did well on this in general, and that is determine validity by means of a truth table, validity or invalidity, okay? And we have as our statement constants A, B, and C. And the argument goes, if A, then C. The next premise is C, the next premise is B, and the conclusion is A and B. Okay. We need 8 rows, because it's 3 of these. 2 to the third is 2 times 2 times 2, which is 8. 4, 5, 6, 7, 8. And we fill these in. True, false, true, false, true, false, true, false, true, true, false, false, true, true, false, false. Now, 4 truths, 4 falses. All right, so let's remind ourselves of our overall strategy, and that is try to show invalidity, okay? And what is that? A case of true premises and a false conclusion. Okay. And so, given that that's what we're looking for, we should calculate the conclusion first, because we can eliminate a bunch of work if we do that. So we're going to do A and B for each of these lines. So I'm just going to do, so it's true, true, false, 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 and false. Okay. Which lines can we eliminate? The ones with which kind of conclusion? True. So we didn't get to eliminate much. Okay. Now, because I'm lazy, I'm going to calculate C, because calculating C isn't tough, right? I just have to rewrite the C column. So the C column, it goes true, false, true, false, true, false. Okay. So now I can eliminate more lines from consideration, because we're looking for a case where all the premises are true. So wherever a premise is false, we can eliminate that line. So everybody got that? So here's a false one, so I'm eliminating it. Here's a false one, so I'm eliminating it. Here's a false one, so I'm eliminating it. So right now we only have 2 candidates left, right? 3 and 7. Okay, let me do B. Right here, B is false on this line, so that means I can eliminate 3 as well. So that leaves us with line 7. What is B on 7? B is false, and so I can eliminate that, and then the argument is what? Did I do this right?
Line 5?
Line 5, I know I made a mistake. Oh, did I skip line 5? Okay, I skipped line 5. B is true, so let's calculate A then C. A then C is false then true, and false then true is true, okay. So there were 3 lines left to do. So we have true, 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 and then a false, and that makes it invalid on line 5. Everybody got that? I knew I was somehow messing up. I skipped this line. Okay. Okay. And if we don't find a line where the premises are true and the conclusion is false, the argument is then what? Valid. Does everybody understand that? Okay. Are there any questions about chapter 3? Are there any types of problems you would like me to work? Last section, someone said, well, the ones with the unknowns bother me, okay? And so I want to point your attention to, right where the homework is in the text, right at the beginning of the homework section, there's like a page or 2 of the chapter summary and notes and hints and stuff like that, right? So you should always look there, but here's one thing to know when you're calculating unknowns, okay? Think about a conjunction. If one part of a conjunction is false, false and anything is what? False, right? Because it takes 2 truths to make an and true. And it doesn't matter if the false comes first or the false comes second. Blank and false is false. Everybody understand that? So if you have a conjunction and you know that one conjunct is false, you don't have to do, so if you're like this, it's false and there's an unknown, you don't really need to do this calculation because false in anything is what? False. Okay, everybody got that? Okay. All right, now there's something you can do with disjunctions too. It only takes one disjunct to make a disjunction true. So if you have true or unknown, it's true. If you have unknown or true, it's true. Does everybody understand that? It just takes one disjunct to make the whole thing true. Okay. Now the conditional is a little bit funky. And now it matters. Up here I said it didn't matter where the false was or it didn't matter where the true was. Here, it very much matters the order of things. If you have false, then anything, that's going to be true. Because remember, when did we say a conditional was false? We said a conditional was false when the antecedent was true and the consequent was false. Well, here, the antecedent is false. So the whole conditional can't possibly be false, because first things first, you need a true antecedent. And we have a false one. So false, then anything is true. Similarly, if you have unknown, then true, you know the conditional is going to be true because it takes a true antecedent and a false consequent in order for a conditional to be false. But our consequent is true. So it can't possibly be false, so the whole thing must be true. Does everybody understand that? Okay. Now the biconditional, it's always, if you have something and an unknown, it's always going to be unknown. Because true or anything, well, if this is true, it's going to be true. If this is false, it's going to be false. It doesn't matter the order. And if you have false, well, if this is true, it's going to be false. But if it's false, it's going to be true, right? And so biconditionals, if you have something and an unknown, that biconditional is going to remain unknown. Does everybody understand that? Okay. Now, one thing I would like to point out, and I would really make sure you write this down. If you are doing some of these unknown things, for example, and let's say you have M and not M, okay? M is unknown. Everybody understands that, right? So we're gonna have to say, well, M could be true and it could be false. And we're gonna and it with not M, okay? Well, if M is true, not M would have to be what? So you have to put a false here and a true there. Does everybody understand that? And then you could do it, you could do this. True and false is false, false and true is false. Does everybody understand that? Okay? Because this is essentially the same thing, if you assume that M is true here, well, not M would be false. And if you assume this is false, not M would have to be true. Does everybody understand that? Because this is the same unknown. Similarly, if I had an or and, wherever you assume this is true, you'd have to assume that is true. Does everybody understand that? Or, let me do and, then, and. Let's do that one. So if I had and, then, and, if I assume this one is true, that one would have to be true. If I assume this one is false, that one would have to be false. And then I would do the calculations. True, then true is true. False, then false is true, right? But if I had and, then, not and, wherever I assume this and to be true, I'd have to assume this one to be false and vice versa. And then I do the calculation. True, then false, 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 then true is true. So this one would remain unknown. Does everybody understand that? So I'm just telling you, if you have the same unknown, wherever you assume that it's true, in one place you have to assume it's true in the other place, right? Unless, of course, it's got a negation with it, and then you have to apply the negation. Okay. Does everybody understand that? That's one thing that might be tricky. I've already talked to you about those other things. So, other questions from chapter 3?